Good morning. So we are talking about writing linear inequalities today. So up to this point, we've written linear equations. We have graphed linear inequalities, but now we're going to combine those two ideas and we are going to write linear inequalities. So just to get you started, you guys are going to do this warm-up question. You've got two representations, a table and a graph. You're going to find the slope and the y-intercept for each one. And that will help you write the equation, right? We need our slope and our y-intercept to write the equation in slope-intercept form. So go ahead and try that now. Pause the video, practice that, and then I'll have the answers for you after the video. Okay, so to get into the lesson, what we want to be able to do is we want to be able to find the slope and the y-intercept. So when you did it up here, right, from a graph, you can look at the slope as rise over run. So that's one of the ways that we have done slope. We've done rise over run, and that is from a graph. So that's one of the ways that we've done it. Okay. We've also looked at slope by looking at tables and finding the change in y over the change in x, right? And that is our slope. So you can go this way. How much is it changing over here versus how much is it changing over here as a fraction? And that's from a table or 2 points. We've used the slope formula. From the y1 minus y2 over x1 minus x2. We have also used Desmos and the regression, the y1 squiggle, mx1 plus b. All right, so those are all different ways that we have found slope, all valid. Depending on which type of representation or what you're most comfortable with will kind of determine what you want to do, right? But you can find those in many different representations in many different ways. Okay, y-intercept, which we've talked less about, but we have talked about it, definitely from a graph, right? On a graph, you're just looking, where does it cross the y-axis? So that's the first way that we talked about. You can do in Desmos, the y1 squiggle, mx1 plus b, and the b is the y-intercept. But you can also think of like up here in this table where x equals 0, so you could evaluate the equation. If you plug in a 0 for x, what would you get for y, right? Or in a table where x is 0, what's y? So the y-intercept up here is 0. Preview for the answer. In a table, that can be in a table or a list of ordered pairs or on a graph, any of those things. Okay, so y-intercept, slope, we have lots of different ways of finding them. And you just have to choose what's best for that time, for that representation. Okay? All right, so real quick, I wanted to remind you that there are the two special types of equations. So when we have a slanted line, we can do the rise over the run, and that gives us our slope. If the line is decreasing, like this one is, it would be a negative slope. If it's increasing, it's a positive slope. But there's also these two special slopes, and remember we gave you the acronym to help you remember. It's Hoy-Bucks. Okay, H in Hoy is for horizontal, because it's a horizontal line, right? Zero, the O stands for the zero slope, because it's not rising or running, the slope is just 0. But what we've spent less time on is that the equation is just y equals. So it's y equals whatever the y-intercept is. So if I look at this graph, the y-intercept is right here at -3, so my equation would be y equals -3. Okay. For the Bucks, V stands for vertical. U stands for undefined slope. And because it has an undefined slope, we actually don't write it as a y equals mx plus b. We write it as an x equals equation. So we just look wherever the x-intercept is, here 2, and this would be x equals 2. That's the equation. So for vertical and horizontal lines, it's just y equals the number for horizontal, x equals the number for vertical. Okay. All right, so we're going to kind of review what we've been doing, but then we're going to use that information to create our equation. So we need to find the slope or rate of change. So we pick any 2 points on the graph. So let's say I pick here and here. Okay, the slope will be how it's changing up and down versus how much it's changing right to left. We're doing rise over run. So we're going down 2 and over 1. So my slope is -2 over 1, which is just -2. The y-intercept is where it crosses the y-axis, which is right here at 0, -3. So my y-intercept is -3. The x-intercept, where it crosses the x-axis. So if my slope is -2, right, it's going down 2. If this is going down 2 and over 1, then this is halfway between that going down 2 and over 1. So the x-intercept is actually at -1.50, because it's halfway. Okay, so whatever your slope is, you can use that as the denominator, right? So it's halfway because it's divided by 2. If it was, the slope is 3, it'd be 1/3 or 2/3. If the slope was 4, it could be 1/4, 1/2, 3/4, right? So just thinking about where you are. Okay, so then once we've got our slope and our y-intercept, we can actually write our equation, because we know that y equals mx plus b is our slope formula. So y equals mx plus b. So we've got y equals, our m was -2, x plus our b, which was -3. Okay, now I don't have to write it like with the plus negative. I could just make this negative, so I would probably just write it as y equals -2x minus 3. But you could have the plus -3, that's the same thing. Okay, so now I've written the equation for this line, but if, let's say, g of x is -2 times f of x, let's say that this one was f of x. Oh, and actually it told me that we're doing the given function f, so really I shouldn't have put y at all, because we want it as a function of x, so let's change that. We're going to make this f of x. Because remember, y and f of x are interchangeable. F of x is just function notation. All right, so if g of x equals -2 times f of x, what would the new linear equation be for g of x? So I'm multiplying, that's what this means, right? The entire equation, f of x, by -2. So I'm going to multiply everything by -2, like the distributive property. I'm doing -2 times -2x minus 3. Okay? So g of x will be that. Okay, so I would get -2 times -2 is positive 4x, -2 times -3 would be positive 6. So g of x is 4x plus 6. So just using that distributive property there because I'm multiplying the entire equation by -2. Okay, so similar idea, but this time they want me to make h of x where I'm doing f of x plus 4. So I'm going back to the original. Don't use this one because that was g. I'm doing f of x plus 4. So here I'm going to add 4 to f of x. So I've got -2x minus 3, and I'm adding 4 to that. Okay, you could put in parentheses. You don't really need it. I needed the parentheses here because I was multiplying, and parentheses is multiplying. So h of x would be that. So if I actually add, which ones would I add? Well, I only add like terms, and the like terms are -3 and positive 4. So -3 plus 4 is 1. So h of x would be -2x plus 1. And that's my new equation. Okay. All right, so let's flip over to the back. There's just a couple things I need to talk about on the back. All right, so now that we're comfortable with writing equations, because we've been doing it and we know we're familiar with that, let's apply that to writing linear inequalities. So it's actually the exact same steps. You're going to find the slope, find the y-intercept, write your equation. But after that, there's an extra step. Okay, so first we determine the equation of the line. So for the one I gave you just the basic y equals x equation. Okay. Once you have the equation, then you have to decide what kind of inequality symbol, right? Because we don't use equal signs. So, you have to decide greater than, less than, greater than or equal to, less than or equal to. And so we do that by the same way we talked about in the last lesson about graphing inequalities. You got to think about, is it a solid line or a dotted line? So this time, instead of having the inequality and deciding if I should do solid or dotted, I have the solid or dotted, and I have to decide which sign is it. Okay, so for a solid line, that's when you do greater than or equal to or less than or equal to. Dotted line is greater than or less than. So for this one, I have a dotted line or a dashed line, so I know it must be either greater than or less than, no or equal to. Okay, so then I look at my graph and I say, is it shaded above? Well, shaded above is greater than or equal to, and shading below is less than or equal to. I already eliminated the or equal to, so is it greater than or less than? Well, it's shaded below. I'm going down underneath the line, under, below, and so it must be y is less than x. Okay, because remember our original equation was y equals x, so all we're looking to do is replace the equal sign with an inequality. Okay. So for over on this graph, it's kind of harder to see on the paper, but this part is shaded, just so we're clear. Okay, but we have to write our equation first, so I'm going to look at the y-intercept and the slope. So let's go y-intercept. I just need 2 points. So, well, as you can see the slope. Okay, I got the y-intercept is there, and then I need one other point. Let's go this one, right? So for the slope, I'm going 1, 2, 3, 4, 5, 6, 7, right? -7 over 1, 2, 2. Okay, and then for the y-intercept, it's up here at 0, 2, positive 2. Okay, so my equation of my line is y equals -7/2 x plus 2. Okay, now, remember that's just the equation, but I don't have an equation. I have an inequality, so I can't stop there. So then we have to think, is it a solid line or a dashed line? Well, this is a solid line, which means it's either less than or equal to or greater than or equal to. And then it is shaded, so that it looks like it's to the left, but if you think about it even like on the number line, left is like going down on the number line, right? So it's still below, it's lower, it's less, but if I pick an individual point, I'm going down from that one point. So either way, I'm going shaded below. So that would be less than or equal to. So I've got y is less than or equal to -7/2 x plus 2. Okay. All right. So then you could practice on the next few, and I'll put a couple answers just so you can see the process. But you are good to work on it. As I was working these 2 guided practice problems, I wrote out my thinking on this one. So if you're stuck or you're struggling to get this, maybe look through these notes and then try to write your inequality from there. But one thing I did want to mention is on this one where we were trying to get it to slope-intercept form, you have to solve for y, right? So if we're solving for y, we're trying to get y alone. And what I came across is, remember that we use the opposite to move the 2x, so it'd be minus the 2x, and then we'd be dividing by the -3, because that's the coefficient to y, we want y alone. But when you divide by a negative with an inequality, you have to remember to flip that inequality symbol. So I just wanted to make sure I mentioned that's super important, that we make sure we flip that inequality symbol. And as promised, I have the answers for the warm-up right there, so you can check your work and make sure you're good to go. Have a great day.